Welcome back, everybody, and here we go again. Continuing our discussion of nomenclature. Well, this example got big, didn't it? I got two copies of the same thing. Let's just look at the second one so you know where the first one, that was just the original. I'm going to number from left to right to get my first group on 3. Yes, there's a second group on 3 as well, but it's the first group that makes the decision. And I actually might edit this to make it even a better example in a second. It's a pretty good example already. All right, so having a group on carbon 3 is the lowest. Oh, don't put it up there. The answer is down here. And I can't do 3s. There we go. That makes this 5, and this 7, and this 9. And clearly, this has to be 10 and 11. The question is, where is 12? Two choices, 12 up here to get a shorter chain, or 12 down here to get a longer chain, and I answered my own question. Nomenclature always must find the longest possible chain. That's a rule. So that makes this 12 going down. And then we go 14, 16, 18, 19. And this is now a group. I'll do my best to recolorize it in black, just to be consistent. Black groups have to end with YL, and the chain is in blue, and it ends with ANE. A-N-E. Why am I leaving so much room? I think I'm going to need all of it. That doesn't look like ANE. How do you say 19 carbons? You say nona, D-E-C, decane. The group. Yes,
Sorry,
hello.
I might have miscounted, but I thought it was 18 instead of 19 at the end.
You are most likely correct. I've had a trouble counting day, actually week. 3, we're good with 3, 5, 7, 9, right? 10, 11, 12, 13, 14, 15, 16, 17, 18. Hee hee ha. We got 2 ways to fix it. Can I make it 19 so I don't have to rewrite my name or the name at the end? Thanks for catching that. Here. Let's just add the extra carbon here. Move the 19. I could have just erased 2. All right, so 19 now, wasn't before. Okay, so our groups, I'll put highlighters on our groups. And I've seen students say, this is a group. This is a mistake to say that's a group. No, that's a group attached to carbon 3. This is a group attached to carbon 3. They are both groups. They both show up in the name. Here's a 3 carbon group. So our groups so far are methyls. And we'll put groups in purple. Just remind you, that's 2 methyls. And a 3 carbon group. Well, if it was a 3 carbon chain, it would be called propane. When it's a group, it's called propyl. We'll skip the bromine for a second because I haven't talked about those yet. But I believe I see another methyl here. And I remember I promised I would edit the question to make it even better. I'm gonna throw another methyl in here and pretend it was there all along, right there, and right there. And move my nonadecane piecewise. There we go. And that also is a methyl. I did it for the purpose of making it a better example. And I need my highlighter. So we have a methyl down. Oh, that's not a highlighter. Highlighters are here. Methyl. Okay. And we have another propyl on top. Let's get our highlighters going. Methyl. We have another propyl. And a 1, 2, 3, 4. It's a butyl. So we have another propyl. And we have a butyl. We have work to do. All right, alphabetically. In the name, there's going to be a prefix in front of methyl because we have 2 here, a third one here, and a fourth here. The prefix in front of methyl is tetra, meaning 4 methyls, tetramethyl. But it does not alphabetize by T. It alphabetizes by the name of the group, M. So M is going to go after B. So it goes B, then M, then P, and I think that's the 3 types of group. So I'm going to take a big risk here and start with the B's. With experience, you might want to just go to the last one and put it here so you don't have gaps or run out of room over here, but I don't mind if you have gaps or run out of room. Butyl's on 11. I need to put 11 in front of the name butyl. 11 has the butyl. 11. Okay. 11 has the butyl. There's only one butyl, no prefix in front. There are 4 methyls. Every methyl needs a number. Okay? Every methyl needs a number. I don't care if there's 2 carbons on 3, they each get a 3. There's 2 methyls on 3. So there's a methyl on 3. There's a methyl on 3. There's a methyl on, next one is 9. Talking about this methyl right here. Last methyl on 17. I didn't put the 17 there, but I know it's a 17. How do you say there's 4 methyls? Well, you start with tetra. Verify your work. If you put tetra there, you better have 4 numbers in front of it. Yes, I do. And the group's called methyl. And I need to put my last group on there, and there's 2 propyl groups. There's one on 5 and there's one on 9. So you say 5, 9, 2 numbers. You get the prefix di and the name propyl. Think I can squeeze it in? Not bad for me. Usually there's a huge gap or things overlapping, but I'm lucky today. All right. So we have the lovely molecule 11-butyl 3,3,9,17 tetramethyl 5,9-dipropyl nonadecane. It just rolls off the tongue. You might ask yourself, what's the formula? And we will do the formula here. How many carbons in a butyl group? Good review here without looking at the molecule. Butyl's 4. We have 4 separate methyl groups that each have 1 carbon. We have 2 separate propyl groups that each have 3 carbons. We've got nonadecane, which has 19 carbons. Better do slow math today. 4 plus 4 is 8, plus 6 is 14, plus 19 is 33. C33H68. 2 times 33 is 36. 2 times 33 is 66. 2 more is 68. And there you have it. We didn't put the bromine in the name. It's all right. We didn't know how to name bromo groups. So there's 4 halogens. We use them a lot in organic chemistry, although they're not found in a whole lot of natural organic molecules. But in the lab, we use them all the time. So we need to know the names for the halogens. The 4 halogens that we use commonly in organic chemistry. And they're going to be attached. So you got your F, you got your Cl, your F is fluoro, doesn't end with YL, it's not a carbon group. Your Cl, you guessed it, is chloro. And your Br, you're asking, what's the squiggle to the left? Well, the squiggle is the chain, okay? And if you see bromine attached to a chain, it's going to be bromo. That's our example, isn't it? And for people that like the sound of words that is unique, I like this one, iodo. It just sounds cool. And fortunately, you know, we can pretend we didn't forget the bromine from the beginning like we did. You can't move a whole page over like that. And the bromo's on 7, and BR is before BU. And that's a bromo. And that's a terrible looking R, isn't it? But, you know, still getting used to my new setup here. Okay, so when do we use numbers and how do you put them in the name? Well, we have numbers sometimes at the beginning of the name, and you don't need a dash in front of those because the dash in front means it's in the middle of the name. Dash is in front. So the first number is followed by only a dash. Numbers in the middle, they preceded by a dash and anteceded by a dash. A group of numbers, the first one gets a dash in front, last one dash after. And I think that covers numbers entirely, doesn't it? So what do we have so far? We know the names of 20 hydrocarbons. Good. We know the name of 20 groups. Methyls, ethyls, propyls, butyls. Up to icosahexyl. That'd be a 20 carbon group. Yes, it exists. We know 4 more groups. Bromo, chloro, fluoro, iodo. So we're at 24 groups so far. And when we pick up on the other side, it's a nice short segment here, we will do newer groups. And we'll have virtually infinite infinite possibilities with the system that we're about to use. And I look forward to seeing you on the other side. So here we go. Working on stopping, and see ya.